Lesson 54.
Velocity and acceleration and motion due to gravity. Okay, what do you guys remember about? We've talked about position, velocity, and acceleration. I know we have. How do they connect to calculus?
Velocity is the derivative of position.
Okay, velocity is the derivative of position. And then acceleration is the second derivative. It's going to be in here. Okay, so basically, if you start with position, you take the derivative and you have velocity. You take the derivative of velocity and you have acceleration. Okay, you've got to know those connections. We've done that before at some point first semester. Don't ask me when, but so, and you can underline, highlight, whatever here, but okay, start with the position function, which sometimes you'll see it as s of t. Here it's x of t. And so if it's position, this is just regular measurement. So like, for example, feet. Okay, so notice what it says. The derivative of the position function is velocity. Okay, so velocity is that first derivative. When you take the, excuse me, derivative of position, it's the change of position with respect to time. And so change of position with respect to time, this is going to be something like feet per minute. Okay? Then the derivative of the velocity function is acceleration. Okay? And then acceleration, your label is like that, feet per minute squared. Okay? Now, before we go into this, some things to connect. The particle is at rest or changing direction. So if your particle's moving, when is it either at rest or when is it changing directions? What has to happen to that particle? If it's at rest or changing directions, it's going to have to stop, yes? When it stops, what is equal to 0? Velocity is equal to 0. So anytime you're asked to find when is the particle at rest or when does it change directions, you're finding when does the velocity equal 0. These are some of the questions you're going to see. Okay? The particle is moving forward or to the right when the velocity is positive. It's moving backwards or to the left when the velocity is negative. That kind of makes sense, I hope. Okay? The particle is accelerating when acceleration is positive. The particle is decelerating when the acceleration is negative. And then the position function tells us the location of the particle. So like where your starting point is. Okay, so kind of just a reference list of things to refer to. Ready to try this? I don't think you'll mind problem 1 at all. I really don't. And I know some of you are going to say, whatever, Mrs. Sargent, but as calculus goes, it's not bad. The position of a particle moving along the x-axis at any time t in seconds is given by the equation x of t equals negative 3t squared plus 4t plus 2. Find the position, velocity, and acceleration when t equals 3. We very possibly have. Again, I'm going to go with it's not bad, but okay, find the position, velocity, acceleration when t equals 3. How do I find position when t equals 3? Plug 3 in, yes? If you are given a position function, you're asked to find the position when t equals 3. We are finding x of 3, if you will. So do the math. Negative 3 times 3 squared plus 4 times 3 plus 2. Can we do this without a calculator? 3 squared is 9 times negative 3, negative 27. 4 times 3, 12, and 2. So negative 27 plus 12 plus 2. 12 and 2 is 14. Negative 27 plus 14 is negative 13. Now, that is the position. Let's put it into words, though. I mean, plugging it in, the number is, the position is negative 13. What does that mean?
It's 13 units to the left of 0.
Okay, so thinking on a number line here, yes. Negative 13 is 13 to the left. And so that's saying that the position when t equals 3 is 13 units to the left of the origin. So position when t equals 3 is 13 units to the left of the origin. Okay. Wasn't horrible, was it? It's a nice gradual start today. Okay, velocity. How do I find the velocity when t equals 3? Yeah. To find velocity, remember, velocity is the derivative of the position function. So we're going to find x prime of t. And we find x prime of t, that is going to be v of t, so velocity. Okay guys, basic derivative work here. What's the derivative of negative 3t squared? Hey, we remember something. Derivative of 4t? Derivative of 2. Okay, so derivative is negative 6t plus 4. So what is the velocity at 3? Negative 6 times 3 plus 4, which is negative 14. Okay, so what does negative 14 mean? Okay. And so, yeah, it's moving 14 units per second. Because it's negative, that's going to mean backward or left. Okay. So velocity when t equals 3 is, and I'm just going to leave it as negative 14 units per second. And you could say moving 14 units per second to the left, I guess.
So our homework, are you wanting us to write out like full statements like that? Want that in the future, or is this just for the sake of the lesson?
It depends. Part of it depends on how it's asked. Okay. But part of this I'm just doing because I feel like we need the word, like the understanding. You know, you tell me the velocity is negative 14. Do you know what that means, or are you just telling me that number because that's what they gave us? Okay. So I don't necessarily remember exactly what homework did. I'd have to look at what the questions are. Okay, acceleration, you got it? How am I going to find acceleration? Yeah, the derivative again. So officially, I'm going to write it as x double prime of t. It's the second derivative. Or you can also think of it as the first derivative of velocity, right? But that's going to be a of t. What is the derivative of negative 6t plus 4? Negative 6. So what happens when you plug 3 in? Yeah, there's no place to put that 3, right? So does it change? No. It doesn't matter what number you put in here for t. The acceleration is always negative 6. That acceleration is a constant. It does not change. Okay. So acceleration when t equals 3 is 6 units per second squared. Okay. Why do I have that written? Oh, okay, this is where I threw the negative in. I see what I did. We're accelerating, it's that 6. Wait a minute, why did I do that? Okay, because what I wrote on here is in negative x direction. Okay. So the acceleration when t equals 3 is that 6 units per second squared in negative x direction is how I wrote it on here. And that's why I was looking, I was like, wait, what? So acceleration at t equals 3 is 6 units per second squared in negative x direction.
That's it.
I mean, the key of that is to find the position, you plug the number in. To find the velocity, you take the derivative, plug the number in. To find the acceleration, take the derivative again, plug the number in, right? Questions before I try example 2? Okay. The position of a particle moving along the x-axis at any time t is given by the equation. X of t equals t squared minus 3t plus 2. Find the times when the particle is momentarily at rest, the times when the particle is moving to the right, the times when the particle is moving to the left. Also find the times when our particle is accelerating or decelerating. So they just asked us like 5 different questions here. All in one, which I will tell you up front, that's typical open-ended AP questions. They're going to ask you everything. Okay, so what all do we need? Find the times when the particle is momentarily at rest, when it is moving to the right, when it is moving to the left, when it is accelerating, and when it is decelerating. Okay, what do I need to start with?
You need velocity equals 0.
Okay, and what's velocity equals 0 going to tell me?
That's going to be the time when it's standing still.
Okay, momentarily at rest, because if something is at rest, it's not moving, yes? If it's not moving, that means its velocity is 0. So we were given the equation, x of t equals t squared minus 3t plus 2. So we first need to find the derivative. So x prime of t, the derivative, is going to yield what? You guys like that? Derivative of t squared is 2t minus 3. And that is my velocity, yes?
So why can't we use position for that?
Because position just tells you where it's at. It doesn't tell me when it stops or starts or anything like that. It just tells me, okay, it's at 5. Or at this time it's at 6. Or this time it's at -8. Or
It could be moving at this position.
it's just telling you the location.
Oh, okay, I thought it was stopping.
No. Okay. So, momentarily at rest means the velocity has to equal 0. Okay, so anytime you're asked momentarily at rest, you're saying your velocity equals 0. My velocity equation is 2t minus 3. So when does 2t minus 3 equal 0?
T equals 3 halves.
Add 3. divide by 2. And so I'm going to say at t equals 3/2, that is my momentarily at rest answer. Okay, what's the next question?
Moving right.
So, how or when am I going to find when my particle is moving to the right? What has to be true? What greater than 0? Velocity. Because my particle is going to be moving to the right when the velocity is positive. So when something is positive, that means it is greater than 0. So if I take my velocity and set it greater than 0, 2t minus 3 greater than 0.
T is greater than.
Okay, add 3, divide by 2. Now it's t greater than 3/2. And so what's happening when the time is greater than 1.5? My particle is moving right.
Why did you use the greater than sign?
Because if we're looking for when the particle is moving to the right, that happens when the velocity is positive. And so anytime something's positive, that means it's greater than 0. So that was just the easiest way to set up. We also technically could use a sign chart at this point. If you put 3/2 on there, and then you put a number left of 3/2 and test it, and a number right of 3/2 and test it, we could also do that. But it's just the idea that moving to the right means the velocity has to be positive. Positive is the same thing as saying greater than 0. If a number is positive, it's bigger than 0. Okay. So the third question, when is my particle moving to the left? When my velocity is what? Less than 0. Okay, because less than 0 means negative. So again, you get the idea of what's going to happen here, don't you? 2t minus 3, less than 0. You solve that, we're going to be at t less than 3/2. So when t is less than 3/2, we are moving left. Yeah, all over the place here at this notebook. Okay. So can you picture what's happening? Okay. Right at 0, what starts happening? It starts moving to the right, yes? Or at time 0, we start moving. No. When t is less than 3/2, we're moving left. So we start moving left. At 1.5, we stop. And then after 1.5, we turn and go back right. Okay? Now, the other question was, when is the particle accelerating or decelerating? Well, officially, in order to do that, what do I have to check right now? Another derivative. So we're trying to find the second derivative of position. Is my acceleration. What is the derivative of 2t minus 3? 2. So 2 is what kind of number? It is positive. Doesn't matter what t I put in. If I put in 1, it's still positive. If I put in 2, it's still positive, right? It doesn't change anything. And so, since my acceleration is constant, what is my particle always doing? Yeah. Particle is always accelerating. If it wasn't a constant, we would do similar to what we were doing previously. And I guess I can put on here, remember, when the acceleration is greater than 0, that's when you're accelerating. If the acceleration had been, when it's less than 0, that is decelerating. I didn't spell something right there, did I? No? Decel. Oh my gosh. Okay. Sorry. Excuse the spelling. Ooh, rough. Okay, you got some of the basics there? Yes, no, maybe? Okay. Before we flip to the back side, we've got to read this little blurb here. Okay, acceleration, guys. Acceleration due to gravity. So an object accelerates towards the center of the Earth at 9.8 meters per second per second. Or in other words, meters per second squared. So anytime you talk, you often see that 9.8 come up in physics problems, math problems. It's there a lot. This acceleration is caused by the attraction of the mass of the object to the center of the Earth and is called acceleration due to gravity. There's also a number that you use if it's feet per second. I want to say it's 16, but I can't remember for sure. Yeah, and I don't know if you do or not, but we will possibly have that at some point. Okay, so that is your acceleration due to gravity. Note that 9.8, and let's flip to the other side. Okay, you got a basic little picture there. Earth's surface here, yes. Okay. When you're going up and away from Earth's surface, that velocity and acceleration are both going to be positive. When you're going back down and towards Earth's surface, velocity and acceleration are both going to be, negative. Okay. Right now.
Yeah.
Okay, so we've got a 4-parter here. In a way, we've done bits and pieces of this back in as early as algebra. Okay, so this relates back to our algebra. We're using the calculus spin on it, though. Okay, a ball is thrown vertically into the air so that its height in meters at any time t in seconds is given by h of t equals negative 4.9 t squared plus 20t plus 2. Okay. What happens when you throw a ball in the air, guys? What shape is created? Yeah, basically it's an upside. Remember that? When you dealt with parabolas and algebras?
I was picturing the ball shape shifting, and I didn't know.
Yeah. The idea that as time passes, what's happening? As time passes, the ball goes up, yes? It hits a certain height. It hits its max. And then it comes back down, right?
Yes.
Okay, so have that in your mind. Okay, A. Find the height of the ball and the velocity of the ball when t equals 1. So how do I find the height of the ball when t equals 1? Plug in 1 into the height equation, right? They're asking for what is the height when t equals 1, and they gave me a height equation. So we're finding h of 1.
So that height, is that acting like the position in the other problems?
Yes. Mm-hmm. The difference is our previous problems on the front side were along a horizontal number line. Okay, now we're talking going up in the air. Okay, so there's more, it's more of a two-dimensional, is that two-dimensional movement instead of just one-dimensional maybe? I don't.
It's still one-dimensional because it's flat. We have no z-axis, so it's not
Yeah.
three-dimensional.
But it's two-dimensional still, I think.
And we're not moving side to side either.
I don't know. Okay.
I don't want to be doing that.
Okay. So h of 1, did you find it? 1 squared is 1, negative 4.9. 20 times 1, 20 plus 2. So 20 and 2 is 22. Negative 4.9 plus 22.
No.
17.7.
So that'd be 17.1. It's a height. So how do I label this? Except we have a specific unit here.
Oh, meters.
It was meters. So this is the height at time 1. Part A also wanted me to find the velocity when t is 1. How do I find the velocity? First derivative, yes? So we're going to be finding h prime of t, which is velocity. And so what is the derivative of negative 4.9 t squared?
Name.
Okay, negative 9.8 t. Derivative of 20t plus 20. 9.8 number. Does that sound familiar, guys? Motion due to gravity, or acceleration due to motion of gravity. Number we just talked about on the front side. So if we want to know the velocity when t is 1, plug it in, right? It's being negative 9.8 plus 20, which is 10.2. Velocity is units per time. So this was meters per second. And this is your velocity at time 1. Okay, B. At what time t is the ball the greatest distance above ground? So think about this ball. It's going, going, going.
So B needs to equal 0.
Yeah. What's happening when that ball gets to its highest point? Okay. There's a science word. Because I wasn't going to throw in the word equilibrium. Okay. It's in our math, it's at its max, right? But what's happening to that ball? It's going to momentarily what?
It's going to stop so that the velocity equals 0.
Right. Momentarily stop or change direction, right? Okay. That's the connection I'm trying to get you to make. That's what I needed to hear. And you guys just keep throwing in your science connections. Okay, so when does the velocity equal 0? Do we have a velocity equation?
Negative 9.8 times t plus 20.
Negative 9.8t plus 20. That's my velocity. I'm going to set it equal to 0. Subtract the 20 over. Divide by the negative 9.8. What is 20 divided by 9.8? Now we're on a calculator type problem. Okay, what?
Wait. What did you ask?
20 divided by 9.8.
Oh, I did multiply. Sorry.
There's the problem. I'm like, whoa.
2.041. I don't know how many decimal places. Oh, you already have it.
Well, okay, so if we're going with the Saxon book, it's 4 decimal places. AP calculus is 3 at most. So you said 2041. Perfect. Okay, so that is, okay, B. At what time t is the ball the greatest distance above ground? So right there, that's when the velocity stops, right? So that's when my ball is the greatest distance above ground. Now, read part C. You've got the whole page, so. How high will the ball go? Well, what did we just find?
Oh, the time is max.
We found the time at which it's the greatest distance above the ground. So what do we want to know now?
The height of that.
That height of that time. So what do I do?
Plug it in.
Take the time we just found and plug it into our original height equation. So we're going to be finding the height at 2.0408. So it's going to be a calculator. It's negative 4.9 times 2.0408 quantity squared plus 20 times that lovely number plus 2. Did we do the math?
22.408.
What's my label there since it's a height?
Meters.
Height is how high something goes. Okay. D. What is the greatest acceleration of the ball? So have we talked acceleration at all in this problem yet? No. What do we traditionally do to find acceleration? Second derivative. So, where are we at? The velocity derivative was negative 9.8t plus 20. Negative 9.8 is our acceleration. It's a trend today. Notice there's no variable. So what's the acceleration at time 0? What's the acceleration at time 20? It's always negative 9.8, right? What is that negative 9.8 indicating? Gravity. Remember what I talked about on the front page? Acceleration due to gravity is 9.8 meters per second, or meters per second squared. Yeah, that's at 9.8. So what's keeping that ball from flying away into outer space? Gravity. So even though that ball is going up at some point and then coming back down, the whole time, what's gravity doing to that ball? It's pulling it back down towards Earth. And so that's why it's a negative acceleration, as it's pulling it back down towards Earth. So, what is the greatest acceleration of the ball? I'm just going to say acceleration is constant at negative 9.8 meters per second squared. McLaurin series is tomorrow.
Jack, are you having physics flashbacks? Is that why you're like rocking over there?
This is fun right here.
There's definitely a physics connection in what we're doing there.
I heard physics.
Except we're doing it the calculus way
It's easier.
instead of the science way. So,
Yeah.
okay, you guys have some work time.
I thought you were going to say we had work to show you, and I was like,
That makes
Yeah, let's check homework.
Are they stroke